Hello everyone, welcome in a new video. In this video we are going to understand about a new scheduling algorithm, which is a priority based scheduling algorithm. Okay, so what basically happen in this scheduling algorithm? What is it? Scheduling criteria. So why its name, similar to its name, means the process having some priority and we have to provide the CPU to according to their priority. Okay, in this case we are not going to see the burst time, that whose burst time is bigger, whose burst time is smaller. No, we are not going to do this thing in this type of scheduling algorithm. We see first of all the priority. If the priority is high for the particular process, so we select that process for the execution, no matter its burst time is very big or very small. Okay, so this is for the scheduling criteria. So highest priority process first will get the CPU. Okay, now what happen if there is a tie? Then what we have to do? So if there is a tie in a priority based algorithm, then it is given in a question that what we have to do. Okay, so if there is a tie, what we have to do is that thing is given in a question. Okay, whether you are solving whether this question come in a gate examination or any examination, if there is a tie, then question gives you that what we have to do in that case. Okay, now this scheduling algorithm is basically of both type. So what is the type of this scheduling algorithm? Non-preemptive and preemptive. Non-preemptive and preemptive. Okay, so if this question come, then we have to find both, or we have to solve this question with both of the schedule, both of the algorithm, both type of algorithm, preemptive way and non-preemptive way. Okay, so this is what the question is, and this is how the question we have to do. Now let's take a question and try to solve this. So we have a processes P1, P2, P3, P4, P5 and P6. We have 6 processes available. Arrival time is 0, 1, 2, 3, 4 and 5. Now after that we have a burst time. Burst time is 4, 2, 3, 1, 2 and 6. Now this is what our main thing is, which is a priority. Okay, now priority is given, priority like 4, 5, 6, 10, 9 and 7. Okay, now it is given in a question that if the number is small, that's we have to take we have to think about that this is our highest priority. If a number is high, then we have to select that process because that is the highest priority. So it is given in a question. In this question, if the number is greater, then it's basically a highest priority. So the highest priority in this particular processes is P4, because a number is what, 10. So after that P5, after that P6, after that P3, after that P2, after that P1. Okay, in some question this is also written that the lowest value is a highest priority, means if we see the lowest value among this is what, a P1. So in some question it is also written that this is highest. Okay, so which process we have to select first is everything, every detail is written in a question. If highest is this, then we have to select P1 first. If highest is the 10th one, the greater value, then we have to select P4. In this question, the highest value, the high value is basically the high priority. So 10 is high, it's a highest priority. So P4 is the highest prioritized process here. Okay, now we have to solve this. So first of all, what we have to do? We have to make a Gantt chart. Okay, so solving this type of question. Okay, so solving this type of a question, we have to make a Gantt chart. Okay, so Gantt chart. Now what we have to do? We have to select, because the Gantt chart is always start from a 0. Gantt chart is always start from a 0. So which process is available at a 0, we have to select that process. So at point 0 we have only one process available, P1. So if only one process available, so there is no matter of a priority, there is no matter of anything. One process is available in a ready queue, definitely CPU will get to that particular process. So at the 0 arrival time we have one process available which is P1, so P1 will get a CPU. Okay, P1 will get a CPU. And first of all we solving this for a non-preemptive thing. Okay, because what I told you that this scheduling algorithm can be solved by both ways, non-preemptive and preemptive. First of all we solve this question with a non-preemptive approach, and then we solve this with a preemptive approach. Okay, P1. Now what we have to do is we have to select a process who have a basically P1, so it's run full because we are solving this in a non-preemptive way, so it execute completely. After 4, now we have to see that which process is basically available. So P2, P3, P4 and P5. Okay, so these 4 processes are available. Now we have to select a process among these 4. So whosoever have a highest priority, we gonna select that process. So among these, here you can see that if the number is greater, then we have to select that process, because the greater number, greater priority. Okay, so among these 4 process, 10 is what a greater, so 10 is the highest priority. We have to select P4. We have to select P4. What is this burst time? Burst time is 1, so definitely it becomes 5. The completion time of P4 become 5. It only execute 1 unit of time. Okay, after the completion of P4, now the arrival time is what, 5, and P6 is also available in a queue. Now we have to select the process in these four processes. Okay, because P1 is completed and P4 is completed, so the processes left is P2, P3, P4 and P6. So among these who have a highest priority, we have to select that process, highest number, highest priority. After then the lowest number is what, 9. Okay, so among these 4 processes, definitely this one have highest priority, so we have to select P5. The burst time of P5 is what, 2, so 5 and 2 become 7. Now P5 is also completed. Okay, 3 processes left, P2, P3 and P6. Okay, so after 9 the lowest value is what, 7. Or among these 3 processes, the highest prioritized process is what, P6. So we have to select P6. Burst time is what, 6, so 7 and 6 become 13. So P6 process is also completed. Now the processes left is what, P2 and P3. So among these 2 processes, the highest prioritized process is P3, because 6 is greater than 5. So P3 is what, highest priority process, so P3 will execute, and the burst time of P3 is 3, so 13 and 3 becomes 16. Now only one process is left in a queue, so that process will get a CPU. So P2 will get a CPU and the burst time is what, 2, so 16 and 2 become 18. So this is how we solve a priority based algorithm. Okay, this is how we solve a priority based algorithm in a non-preemptive way. Now we are going to solve this question in a preemptive way. So if you want to solve this question in a preemptive way, what we need a calculation table. Okay, so we need a calculation table of burst time, because now if in any arrival time, when arrival time changes, so next process come, if that process has highest priority, then we have to supply CPU to that particular process. So the current running process will have to leave the CPU. So if the process is not completely execute, so definitely it will leave some burst time. Because it want to execute again, because it cannot completely execute. So that calculation of burst time we have to do in this particular table. Okay, so 4, 2, 3, 1, 2 and 6. Okay, now we are gonna solve this question. Okay, so now we solve this question in a so now we are solve this question in a non-preemptive way. Okay, so we are solving this question in a non-preemptive way. So first of all, the Gantt chart is always start from 0. Gantt chart is starts from a 0, and at 0 which process is basically available at point 0, only one process is available, which is P1. So P1 will get a CPU. And how much time the P1 will get a CPU? Only one. Why? Because at 1, when the arrival time become 1, so we have one more process available in a queue, which is P2. Initially one process, which is P1, now P2. Two processes available in a queue, so we have to select between these two processes. Okay, so P1 execute only once, so the burst time left is what? 3. Among these two processes, P1 and P2, whosoever have a highest priority, we have to select that process. So P1 and P2, 5 is greater, means P2 have a highest priority, so P2 will get a CPU. How much time will P2 get a CPU? Only 1. When the arrival time become 2, so we have one more process available, which is P3. Now we have 3 processes available, P1, P2 and P3. Now we have to select the process among these 3. Okay, so P2 is execute 1, so the burst time left is what? 1. Now among these 3 processes who have a highest priority, we have to select that process. So 4, 5, 6. 6 is greater than 4 and 5, so P3, we have to select P3 process. So after P2, P3 will get a CPU and it only execute once. Because now the completion time become 3. For the rest of the processes, because why I stop 3? Because at 3 now we have one more process available, which is P4. So if the next process available, so we have to select the process among these 4. Okay, so P3 is also execute once, so the time left is what? 2. Okay, now we have a processes available, P1, P2, P3 and P4. Among these 4 processes who have a highest priority will get a CPU. So P4 have a highest priority, P4 will get a CPU. Okay, and the burst time of P4 is what? 1. The burst time of P4 is 1, so the completion time will become 4. Completion time of P4 become 4 and P4 is completed. If P4 is not completed, let's say the burst time will become 2, so the completion, then also we have to stop at 4, because at 4 we have one more process available, which is P5. So among the 5 processes we have to select, then also we have to select P4 because it's a highest priority process. So if all the processes are available, then also we have to select P4 because of the priority. Here the burst time is 1, so definitely it complete at 4. Now at 4 we have one more process available, which is P5. So 4 processes available in a queue, P1, P2, P3 and P5. Among these 4 processes who have a highest priority will get a CPU. So here P5 process have a highest priority, so P5 will get a CPU. Now P5 will execute completely. Okay, why I said that? Why P5 not stop at 5? Because at 5 one more process is available, P6. Why P5 not stop at 5? It completely execute. Why it execute till 6? Because of the priority. At 5, I agree that one more process is available, but among these 4 processes, definitely P5 have a highest priority. So P5 will again get a CPU and P5 execute till 6, till the P5 is not completed. So P5 is completed and now the completion time becomes 6. Now P6 process is also available. Now we have a processes left is what? Left is P1, P2, P3 and P6. So among these 4 processes who have a highest priority will get a CPU. So P6 have a highest priority, P6 will get a CPU. Now no more processes are coming in a ready queue, so we have to execute full processes. Okay, so the completion time of P6 will become 6 and 6 12. The completion time of P6 will become 12 because of burst time is what? 6. So add 6 become 12. P6 is also completed. The processes left is P1, P2 and P3. So those who have a highest priority will get a CPU. So P3 have a highest priority, P3 will get a CPU, and the burst time left is what, 2. So 12 and 2 become 14. So P3 is also completed. After that, P2 process and P1 processes are available. So P2 have a highest priority, so P2 will get a CPU, and the completion time is what, 1, burst time is what, 1, so the completion time become 15. After that, one process available which is P1, so P1 will get a CPU, and the completion time become 15 to the burst time is what, 3, so 18 is the completion time. Okay, so this is what for the preemptive thing. This is how we solve a priority based algorithm in a preemptive approach or by non-preemptive approach. This is how we solve. Now we have to check that the Gantt chart basically made is correct or not. So the completion time of a last process is what, 18. So if you sum up all the burst time, you will get 18. It means that we make a correct Gantt chart. Okay, so this is how the question of priority based algorithm is solved. Okay, so I hope it is clear to you that how we solve this particular type of a process is very easy to solve. We are going to solve one more process one more question. In that question, what we are going to do is, in this particular type of a question, we make the highest number highest priority. In this question, what I am going to do is, the lowest number have a highest priority. So the processes available is P1, P2, P3, P4, P5, P6. So 6 processes available. Arrival time will become 0, 1, 2, 3, 4 and 5. Burst time will become 7, 3, 5, 7, 3, 5, 2, 6 and 1. Okay, now the main thing is priority. So priority is what, 9, 4, 2, 1, 3 and 8. So in this question, the lowest number is highest priority. The lowest number have a highest priority, means among 1 and 9, 1 is smaller, so 1 have a highest priority. Smaller number highest priority in this question. And now you have to solve this in both the approach, in a preemptive way and a non-preemptive way. Okay, pause the video, solve this and comment down the average turnaround time and average waiting time of this particular question. Okay, and same thing you have to do with this question as well. Okay, because that's a easy thing. What you have to do is turnaround time minus the completion time. You will get the completion time minus the arrival time. You will what you will get a turnaround time, and when you minus burst time in a turnaround time, you will get a waiting time. So you can easily find average T8 and average waiting time. Okay, now for a non-preemptive way, so non-preemptive way, easily we can do that. Gantt chart is started from a 0. Now at 0, one process is available which is P1. So definitely if one process is available, we have to select that one process. Okay, so P1, P2 and P3, one process available, we have to select that process. So P1 will get a CPU. The burst time is what, 7. We are solving this in a non-preemptive way, so definitely whole process execute. Okay, so the completion time become what, 7. After that 7, now the arrival time would become 7. So now all the processes are available, P2, P3, P4, P5 and P6, and P1 is completed. All these 5 processes are available, so those who have a highest priority will get a CPU. And how we can see that which process have a highest priority? By seeing the priority number. So lesser number, highest priority. So among these 5 processes, P4 have a less number, which is what, 1. So what we have to do? We have to assign CPU to P4. The completion time of P4 is what, 2. The burst time is what, 2. So 7 plus 2, so become 9. So 9 is the completion time for P4. Now P4 is also completed. 4 processes left, P2, P3, P5 and P6. So those among these things who have a highest priority, we have to select. So 2 is the bigger number than P4, or you can say smaller number among these 4 processes. A smaller number, highest priority, P3 will get a CPU. Burst time is what, 5. So 9 plus 5, if you add 9 and 5, it become 14. So 14 is the completion time for P3. P3 is also completed. 3 processes left, P2, P5 and P6. So after among these 3 processes, the highest prioritized process is what? The P5 is the highest prioritized process. So P5 will get a CPU. The burst time of P5 is what? 6. So if you add 14 and 6, it becomes 20. So 20 is the completion time for P5. 2 processes left, P2 and P6. Among these 2 processes, the highest prioritized process is P2 because 4 is lesser than 8 and less number highest priority. P2 will get a CPU completion, but the burst time is what? 3. So 20 and 3 become 23. So P2 is also completed. 1 process left, which is P6. Now P6 execute. The burst time is what? 1. So 23 to 24. So this is a Gantt chart for a non-preemptive process. What you have to do is you have to write the completion time, turnaround time and waiting time, and find the average of TAT and average of turnaround time and waiting time, and comment down your answer. Okay. Now the next thing what we have to do is we have to solve this question with a priority based algorithm. Okay, with a priority thing. So priority thing, this is what we make a for the priority one Gantt chart. Now if you solve any type of a priority based algorithm, what you have to do is you have to make one more extra column. Okay, I rub this, but smaller number highest priority you have to think. Okay, now calculation part for the burst time. Burst time is what? 7, 3, 5, 2, 6 and 1. Okay, now we are solving this with a for a priority type of an algorithm. Okay, so at 0, 1 process available, which is P1. So P1 will get a CPU. How much time will P1 run? Only 1 unit of a time, because when the arrival time become 1, so 1 more process available, which is P2. So now we have 2 process. We have to select the process between these 2. Okay, this is what happen in a priority. This is what happen in a preemptive thing. Okay, so this is what a preemptive. Okay, not priority, preemptive. Okay, so P1 will get a CPU first, execute only once, so the burst time left is what? 6. After that P2 and P1, both the processes available. We have to see the priority 9 and 4. So definitely P2 have a highest priority. So P2 will get a CPU. Now the P2 get a CPU. How much time will it execute? Only 1 unit of a time, because when the arrival time become 2, 1 more process available, which is P3. So it only execute 1. So the burst time will be left is what? 2. Among these 3 processes, those who have a smallest number or highest priority will get a CPU. A smallest number among 9, 4 and 2 is what? 2. So P3 have a highest priority. P3 will get a CPU. It execute only once. So the one, why? Because at 3 P4 process is also available, so it only execute once. Okay, now 4 processes available, it execute only once, so the burst time left is what? 4. Now we have 4 processes. The highest priority process is what? P4. So P4 will get a CPU, and the burst time of P4 is what? If I write like 4, because at 4 1 more process available, which is P5. Okay, so P4 execute at till 4, but this thing is not happen, because among all the processes P4 have a highest priority. So P4 will definitely execute completely. So it will not stop at 4, it will stop at 5 till the completion of a burst time. So P4 is now completed. Okay, so the completion time of P4 will become 5. Now all these processes available, P5 and P6, because now arrival time will become 5. The processes left is what? P1, P2, P3, P5 and P6. So now those who have highest priority will get a CPU and execute completely, because now the ready queue is looking like this only. Okay, no more processes are gonna add. So among these things, the highest priority process is what? P3. So P3 will get a CPU. Now the completion time for P3 is what? 4. So 5 and 4 become 9. 5 and 4 become 9. So P3 is also completed. Next highly prioritized process is what? P5. The burst time is what? 6. So 9 and 6 become 15. So the P5 is completed at 15. P5 is completed at 15. Okay, P5 is completed at 15. After that, P5 is completed. Now the process left is what? P1, P2 and P6. The highest priority process is what? Of P2. So P2 will get a CPU. P2 will get a CPU. So from 15, from 15 the completion time will become, for the P2 the completion time will become, add 2 in 15, you will get 17. So for the, now P2 is also completed. The processes left is what? P1 and P6. Among these two processes, P6 is a highly prioritized process, so P6 will get a CPU. The burst time of P6 is what? 1. So 17 to 18. Now one process is left, which is P1. So P1 will get a CPU, and the burst time is what? 6. The burst time left is what? 6. So 18 and 6 will become 24. So this is how the question of priority, this is how the priority based algorithm questions is solved in a preemptive way and a non-preemptive way. Okay, here you can see, if you sum up all the burst time, you will get 24. If you get 24, it means you make a correct Gantt chart. Okay, so the completion time of a last process in a Gantt chart should be equal to the sum of all the burst time. Then it means what? It means you made a correct Gantt chart. Now after that, what you have to do is find the average turnaround time and average waiting time. Okay, so this is a very easy thing, so we are not gonna solve this thing in this video. The main purpose of this video is to understand how the priority based algorithm is solved in a preemptive and a non-preemptive way. Now the next thing is the advantage of this scheduling algorithm. So the advantage of this scheduling algorithm is the better response time for the real-time scenario. Better response time for a real-time scenario, real-time situations or scenarios, whatever. Okay, in a real time, this scheduling algorithm is highly implemented. This scheduling algorithm is used to solve, okay, this scheduling algorithm is used to solve a questions. Okay, so this is what the advantage of this scheduling algorithm. Okay, after that, so this is what one advantage of the scheduling algorithm. Now the next thing is what the disadvantage. There are some disadvantage as well of this particular type of scheduling algorithm, like low priorities process may suffer from a starvation. Here you can see that the ninth one, those who have a smallest priority basically get a CPU at last. Here you can see that P1 is at last in a preemptive based. And similar case with this, the lowest priority process is what? P4, because in this case the highest number, highest priority. Okay, so 4 is smallest, so 4 is what? P1 process. So P1 process get a CPU at last. So this thing happen in this scheduling algorithm. Lowest priority process may suffer from a starvation, means it's a very long time that this process will get a CPU. So lowest or low priority process may suffer from a starvation. Okay, or what is the disadvantage? And the disadvantage is like this is what basically a disadvantage. Okay, now because starvation is there, so definitely this is one of the biggest disadvantage of this scheduling algorithm. And now everything is clear. So I hope you understand by advantages and the disadvantages as well of this particular type of scheduling algorithm. Now we see the disadvantage. Now how we solve this disadvantage, how we overcome the starvation problem. Is there any way to overcome a starvation problem? Because every scheduling algorithm we see that sometimes starvation occur or sometimes conway effect occur. So there is a solution of this starvation problem. So a solution of starvation. So is there a solution of starvation problem? So the answer is yes, there is a solution of this starvation problem. What is the solution of this starvation problem? Aging is the thing which is used to solve this starvation problem. Aging, okay, aging is a thing which is used to solve this starvation problem. What we are going to do is, with a dynamic priority thing, we can put the lowest priority process, okay, with dynamic priority for process. Now what does this mean? This means that if we change the priority, then it means we can run that process as well, okay. So this thing was done by the aging, and this priority is basically of two types. Priority is of two types. The thing we studied now is what priority is what fixed. So this is called a static priority. Static means fixed priority. Fixed priority. Static means fixed priority. And the next thing is what a dynamic priority. So with the help of dynamic priority based algorithm, we can solve this particular disadvantage, which is what a starvation. So what happen in a dynamic priority dynamic thing, what basically happen is, those who have a lowest priority will also get a CPU as compared to the other highest priority process. Why? Because we change the operating system, change the priority according. This thing was the starvation problem basically solved by the dynamic aging, okay, or dynamic priority, where priorities are changing, okay. So priority may increase or decrease. Priority may increase or decrease. Now what is basically aging is, if I have to define aging, then what is aging? Aging, it is a process which wait for a predefined time, then its priority is increased by 1. This is what happen in a this is what happen basically in aging. Priority is increased by 1. Priority is increased by 1. So if a process wait, for example, let's take an example as well to understand this aging thing. Process P1, P2, P3, the P1, the priority of P1 is what, 10, priority is P2 is what, 2, and priorities of P3 is what, let's say 1. And so many processes are available, but P1 is a process who not get a CPU for a very long time. Why? Because in a ready queue, smallest priority process come, or you can say highest priority process, highest priority process, the smallest number, highest priority. So the highest priority process come in a CPU, so the lowest priority process will not get a CPU. So this thing was solved by aging. What happen is, the priority increase or decrease accordingly. Here in this case, the lowest number, highest priority. So what happened in this case, the 10 is decreased by 1, become 9, then become 8, then become 7, then become 6. So at one particular time, the P1 have a highest priority. P1 will have a highest priority. So definitely P1 will get a CPU at that time. So I hope you understand the concept of aging, how we solve a starvation problem. This is a very smallest priority, because if we see a real implementation, then we have a lot of processes are available. So if one lowest priority process comes, so it definitely, if it go in a starvation, then definitely there are lot of highest priority process. So how is we give CPU to that lowest priority process? By decreasing their priority, in this case. If we say that the highest number, highest priority, so what we do, we increase the value. So we increase or decrease accordingly, the system increase or decrease accordingly. So if a process wait, so what we can do, wait for a predefined time. Predefined time means, because we know that this process will get a CPU, but at what time we don't know. So at predefined time, this is what we say, at predefined time. If a process wait for a predefined time, then its priority is, priority is increase or decrease. Its priority is increase or decrease. Okay. Why? If you want to write a reason as well, so you can write it, because if a process wait for a long amount of time, so it increase their priority. So it's good if I write increase the priority. Decrease or increase is understand for your understanding, but in a real thing, what you have to do is what you are doing here. You are increasing the priority of a pre1, and when you at one particular time when you increase the priority, then definitely it will get a CPU. Okay. So what aging is, if a process wait for a predefined time, then its priority is increased by 1 unit. Okay. So this is what happened in a priority based algorithm. So I hope it is clear to you. If you want to understand by yourself, you want to write an explanation, so you can write it as like this as well, like after waiting for a long, the increase in a priority will make the process the highest prioritized process. So at some point of a time, that process will definitely get a CPU. At some point of a time, process will get a CPU. Okay, so you can write it at this as well. So this is what an aging. This is what advantage and disadvantage of priority based algorithm. This is all about a priority based algorithm. Okay, so thank you for watching this video. Like the video and subscribe my channel, and click on the next video to understand about round robin scheduling algorithm.